Today we're going to be looking at a real-life problem that involves proportional reasoning. And the way that we're going to solve this problem is by using a graph. So let's begin by looking at the question. The question says that a standard punch requires 2 cans of orange juice and 1 bottle of ginger ale. When using 4 bottles of ginger ale, how many cans of orange juice are needed for the punch? Now, because we're going to solve this problem by graphing, we have to think about whether or not there is a relationship between two quantities in this question. Well, let's look at the question. What are the two things that are being compared? We're looking at cans of orange juice and bottles of ginger ale. Do you think there's a relationship between the two? Of course, because in order to make the punch, we need to add orange juice and ginger ale. Now we know that in order to draw a graph, we have an x-axis, which is our horizontal axis, and a y-axis, which is our vertical axis. We're going to represent ginger ale and orange juice on each of these axes. So let's represent number of bottles of ginger ale on the x-axis and number of cans of orange juice on the y-axis. So let's make our graph to represent this problem. Well, remember, every graph needs a title. What would be a good title for this graph? How about making punch? We also need to come up with a scale for our graph on each of the axes. What do you think would be a good scale for the x-axis? Well, let's think about the information that they gave us in the original question. The question tells us that the punch requires 2 cans of orange juice and 1 bottle of ginger ale. When using 4 bottles of ginger ale, we have to figure out how many cans of orange juice are needed. Well, since we've chosen to represent ginger ale on our x-axis, let's see what values we're working with. We know that we have 1 bottle of ginger ale to represent on this graph, and we also need to represent 4 bottles of ginger ale somewhere on the graph. So we need to figure out a scale that shows 1 bottle all the way up to 4 bottles. What do you think would be a good scale? Well, since the smallest number is 1 and the largest number is 4, we can just count by ones. So let's start at 0. I'm going to use 2 spaces to represent 1. I'm going to use another 2 spaces to represent 2. And because we're counting by ones, each time I skip 2 spaces, I increase my number by 1, from 0 to 4. How about for the y-axis? Well, the smallest number of cans of orange juice is 2, but do we know the largest number of cans of orange juice we're going to use to represent on this graph? No, because that's the information we're trying to solve for. So we know that we start with a value of 2, and we don't know how high we need to go. So what do you think would be a good scale for our y-axis? Do you think we should count by ones, or 2s, or 3s, or 4s? What would be a good value? Sure, let's skip count by 2s. So once again, we're starting with 0, and I'm going to use 2 squares to represent the value of 2. I'm going to skip another 2, and I'm counting by 2s, so the next point would be 4. 2, 4, 6, 8, 10, 12, 14. We'll stop there. Well, now what? What do we need to do to complete this graph? Well, every graph should have points plotted on it, so we need to figure out what points are we going to plot on this graph. Well, as you may have already learned, when plotting points on a graph, we start with the x value, and then we use the y value. These two values make up a point that is referred to as a coordinate. Well, since we have ginger ale represented on our x-axis, we're going to put the number of bottles of ginger ale that are needed to make this punch. We know that we need 1 bottle of ginger ale and 2 cans of orange juice. We just came up with the first point. So we're going to start at 0, move 1 space along the x-axis, and 2 spots up to show our point of 1, 2. Is there another point you could represent on this graph just by thinking about this question logically? Well, think about it. If you have 0 cans of ginger ale, how many cans of orange juice would you need? 0, because you haven't started. You haven't made any punch yet. So let's plot that point. 0, 0. Now we need to come up with other points on this graph. So let's see if we can see a pattern. What's happening here? Well, we started at 0 and we added 1 bottle of ginger ale. And when we added the 1 bottle of ginger ale, we added 2 bottles of orange juice. So if I add 1 more bottle of ginger ale, how many more cans of orange juice should I have? Well, according to this pattern, we would add another 2 cans of orange juice. Let's plot that point. So let's write down the second coordinate that we just plotted. 2, 4. Let's keep going to extend our graph. If we add another bottle of ginger ale, we're going to add another 2 cans of orange juice. And remember, looking at our scale on our y-axis, when I jump 2 spots, it shows an increase of 2. So let's plot the fourth point. Here we have a coordinate of 3, 6. Are you noticing a pattern? What's the pattern that you're noticing? Every time we increase our x value by 1, we increase our y value by, that's right, 2. So let's do this again. Add another bottle of ginger ale, we're going to add another 2 cans of orange juice. So let's plot that point. And that point is represented by the coordinate 4, 8. So now we've completed the graph. Well, what was the question asking us? Let's look back at the original question. When using 4 bottles of ginger ale, how many cans of orange juice do we need? Well, let's find that point on the graph. 4 bottles of ginger ale. Here's the point. How many cans of orange juice was that? 8. This point is represented by 4, 8. Ginger ale and orange juice. Therefore, we need 8 cans of orange juice for the punch when we use 4 bottles of ginger ale. Can you think of other information you can gather from this graph? What if I asked you, how many bottles of ginger ale do you need when you have 6 cans of orange juice? Well, if we know the value of orange juice, we're going to look at the y-axis. For 6 cans of orange juice, how many bottles of ginger ale do we need? Correct, 3 bottles. Look at all this information we can get from this graph now. Think about how you could actually extend this graph to gather even more information. What if I wanted to know how many cans of orange juice for 5 bottles of ginger ale? What about for 6 bottles of ginger ale? 7, 8, 9, 10? How far can we go? I want you to try extending this graph to gather more information. Maybe even try recreating a new graph using a different scale. What about if you made a new graph and you plotted number of ginger ale on the y-axis? Think about how the graph would change. Try it. Come up with a new graph and submit it to your teacher. Remember to label your axes, have a title, and come up with a reasonable scale. Now we've answered this question using a graph. Can you think of another method we could have used to solve this problem? Check out our playlist for other methods of solving this exact same question.